And due to load diversity, the code permits the application of Table 220.42, demand factors of the total connected load. Basically what that means in English is, hey, we're not going to be turning on all the lights all at once, right? We're going to have some lights on in this room, and these lights are going to be off. Some of these receptacles are going to be used in this room. Some of the receptacles aren't used at all. So you're saying load diversity, that's really what that means, is we're not going to use everything all at the same time. So they allow us to derate these values to accommodate for that, knowing that you're really not going to need all of that load all at once. Okay, again, dwelling unit. So we've got lighting and receptacle loads. We're going to do an example here. So remember that 3 volt amps per square foot includes all of our general use receptacles, all of our receptacle outlets, and all of our lighting outlets. That's all included in that 3 volt amps per square foot. The floor area, remember that's calculated from the outside dimensions of the building, not the inside dimensions. So let's take a look at one. What is the general lighting and general use receptacle, small appliance, and laundry demand load for a 6,000 square foot dwelling unit? All right, so we're going to take a look at that one, and we are going to switch around some views here. And I want to maximize the size of this darn thing so that you guys can see that a little bit better. Yep. Take me just a second here. There we go. That's what I wanted to do. All right, so now you guys can see that a little bit better here. So we got 6,000 square feet, right? So what we're going to do is we're going to apply the information that we have there in the first step, which is we're going to take our 6,000 square feet, it's a big house, right, times 3 volt amps per square foot. And that's going to give me 18,000, right? And then we're going to add our 2 small appliances, and they're 1,500 apiece, right? So that's 3,000. And then our laundry. And that's going to be 1,500. So what we'll do is we'll add all that together, and let's see if I've got that added right here. This is going to be 22,500. So now that 22,500, what we're going to do is we're going to take and apply Table 220.42. And Table 220.42 says, hey, give me the first 3,000 at 100%. That's pretty easy math right there, right? Just make it 3,000. And then the balance, the rest of it, it says 3,001 to 120,000. The easiest way to reconcile that is just pull 3,000 off of this. So that's going to be 19,500. And we're going to do that at 35%. Okay? So that's going to be at 35%. So let me break out my calculator again. I said you can't bring this calculator into the exam, right? And that is true. You cannot bring this calculator into the exam. But if you have your own calculator, a lot of times they'll allow you to bring that in. If you don't have one that you want to use, then they will provide one for you to do your calculations at the exam center. So now I take my 19,500 and I'm going to do that times 35%. And I got 6835. And now this is the part that a lot of people forget, is we need to add these two values back together. Okay? So I take my original 3,000 at 100% plus my 6835. That gives me 9835. All right? 9835. So that would be our calculated demand load for that particular circumstance. So let's take a look here. We'll switch over to this. So I got my 6,000 square feet. 6,000 square feet times my 3 volt amps per square foot, that's 18,000. And then my 2 small appliances, that's going to be 3,000 plus my laundry at 1,500. That adds up to a total of 22,500, right? Of that 22,500, my first 3,000 is going to be at 100%, so that's going to be 3,000. And then I take my balance, my 22,500 minus my 19,500, or I'm sorry, minus my 3,000, and that'll give me 19,500. And we're going to do that at 35%. Why 35%? Because table 220.42 says to do that, all right? So 19,500 times 35% is going to give you 6825. And so we add that 6825 back to the 3,000, we get 9825. All right, so I want you guys to work this one out here. What's the general lighting and general use receptacle, small appliance, and laundry circuit demand load for a 4,000 square foot dwelling unit? Go ahead and pause the video and see if you can work that out yourself. Remember, 3 volt amps per square foot. Don't forget the small appliance and the laundry loads. And then to derate it using table 220.42. Okay, let's take a look at the solution on this one. So we've got our 4,000 square foot. We're going to take that times 3 volt amps per square foot. 4,000 times 3 is 12,000. So that's 12,000 volt amps. Then I'm going to have my 2 small appliance circuits. 1,500 times 2, that's 3,000. Plus my laundry circuit, that's 1,500. That's going to give me a total of my 12,000 plus my 3,000 plus my 1,500, 16,500. Of that 16,500, we'll take our first 3,000 at 100%. That's going to be 3,000. And then we'll take our remainder, 13,500 at 35%. So 13,500 times 35% is 4725. My total calculated demand load is 7725 in that example. So that's really the first step, is to do the square footage times 3 at our 2 small appliance and our laundry load, and then derate it using table 220.42. Now, fixed appliances, what we have is a rule on there that says if I've got 1, 2, or 3 of those, we're going to do those at 100%. If I have 4 or more, then we can do those at 75%. And again, the criteria, the thinking there is that, hey, I'm probably not going to be using every single appliance all at the same time. So it says fixed appliances include garbage disposals, dishwashers, trash compactors, and so forth. The demand load is determined by applying a 75% demand factor to the nameplate rating when there's 4 or more appliances. So here we've got a bunch of appliances, right? I have 4 or more appliances. I've got a built-in microwave. I've got a tankless water heater, a compactor, a disposal, a dishwasher, and by the way, I've got a water heater as well. All right, so I've got a total of 1, 2, 3, 4, 5, 6 appliances, right? That's 4 or more. So what we're going to do is we're going to take the nameplate value of all these. This is just information that I've provided for you on the graphic. That's a 12 amp, 120 volt dishwasher. So 12 times 120 is 1440. And so that's how we get the 1440. My garbage disposal is 10 amps at 120 volts. That's 1200 volt amps. My trash compactor is 8 amps at 120 volts. 8 times 120 is 960. My microwave is drawing 16 amps at 120 volts. That's 1920 volt amps. That's a big microwave. My water heater at 240 volts is 4,500 watts. Now, watts and volt amps, we're going to use those interchangeably. I'll show you here in just a second why we do that, okay? Our tankless water heater, that's 40 amps at 240 volts. That's 9,600. And so that gives us a total connected load of 19,620. And then we'll take our 75% demand factor on there, because I'm not going to run all that stuff all at the same time. I'll never run the water heater, the The tankless water heater, the microwave, the compactor, the disposal, and the dishwasher all at the same time. So I can take the demand factor on that of 75%, and that gives me 14,715. All right? So now I told you that we're going to use volt amps and watts interchangeably, and that's because of this little circle that we have here, right? And so we got a couple of different circles here. One of them I call the pi circle, P-I-E, right? And then there's another one that is called the Ohm's law circle. I call it the ear circle, okay? I know it's E-A-R, E-I-R. It works for me, right? So if we're taking a look at this, this is power, right? And power is expressed in watts, right? This is our intensity in amps. And this is our E, electromotive force, in volts. Okay? And then over here, again, I have volts, right? And then I have amps here. And then this is our resistance in ohms. All right? Also indicated by a symbol that looks like this. Sometimes on the exams, they'll ask you, what's the symbol for ohms? And it's the omega symbol, the Greek omega symbol, okay? So the way that you use this is if I'm trying to figure out what my amps are, I cover up over that I, and my equation becomes my watts divided by my volts. If I'm trying to figure out what my volts is, I take my watts divided by my amps. Same thing over here, all right? If I want to find what my volts are, I take my amps times my ohms, all right? So here, watts is equal to amps times volts. Amps times volts is volt amps. So we use those interchangeably because mathematically watts and volt amps are the same. Now I know that doesn't work out electrical theory-wise, but when we're doing our calculations, we'll interchange those watts and volt amps, okay? So that's why we do that. Okay, so here's one. You guys go ahead and work this one out. This is very small, right? What's our service demand load for a dishwasher? 1,200 volt amps. A disposal, garbage disposal, 900 volt amps. And a water heater at 4,500 watts. You guys work that out. Well, here all we have is 3 appliances, right? So do we apply the 100% or the 75% demand factor on this? No. So we're just going to add those values together. We got 1,200 plus 900 plus 4,500, 6,600. Because we have so few appliances, it is more likely that all that stuff's going to be running at the same time. So we're not allowed to apply our 75% demand factor. All right, so dryers. 220.54 talks about dryers. It says when a dryer is to be installed, the larger of the nameplate rating or 5,000 watts must be used. So our nameplate rating or 5,000 watts. So what's our service demand for a 4,000 watt dryer? Well, it's 5,000 or the nameplate, whichever is larger. And so in this case, we'll do 5,000 watts, right? So our load for electric clothes dryer is not permitted to be less than 5,000 watts or the nameplate rating if the equipment's more than 5,000 watts. What's our service demand load for a 5,500 watt dryer? Well, is 5,500 larger than 5,000? Yep. Then we're going to go ahead and use 5,500 as our calculated demand load. All right. Electric cooking equipment, so that's real simple. Okay, we're just dealing with single-family dwellings right now. It gets a little more complicated when we're doing multifamily. We'll get into that table that talks about multiple dryers. But now we're going to take a look at electric cooking equipment. Our demand load for electric cooking equipment is determined in accordance with 220.55. 220.55. And table 220.55, I've blown that up and cleaned it up a little bit here for you. These are our demand factors for household cooking appliances, electric ranges, wall-mounted ovens, counter-mounted cooking, and other household cooking appliances. All right, so column A is for less than 3.5 kilowatts rating. Column B is for 3.5 kilowatts through 8.75 kilowatts. And then column C is basically over 8.75 kilowatts through 12 kilowatts. So again, note number 1 says, hey, if I've got more than 12 kilowatts, we're going to increase our column C value by 5%. I'll show you how that's done. And then note number 3 down at the bottom says, hey, you could use column C in all cases if you wanted to, out in the field, right? On the test, we're probably going to have to calculate A and B. But if I have to calculate A and B, it says, do all your calculation under column A, do all your calculation under column B, and then add those values together. So what's our feeder service demand load for 2 3-kilowatt counter-mounted cooking units, right? Or those ovens. Yes, they're ovens, sorry. So I got 2 3-kilowatt ovens here, right? And so those 3-kilowatt ovens, what column do they fall into? Column A, column B, column C? Well, that's going to be column A, right? So those are ones that are less than 3.5 kilowatts. So what I do is I go down to my number of appliances, 2, and then I go over to column A and it tells me 75. 75 what? Percent, right? So what we're going to do is take our nameplate value of those 2 ovens, in this case 6 kilowatts total, and we'll take that times 75%. 6 kilowatts times 75%, that's going to give me 4.5 kilowatts or 4,500 watts. Okay? So that's our demand load for those 2 ovens. Now, what about if I've got a 6 kilowatt counter-mounted cooking unit? How many appliances do I have? I've just got 1, right? And so if I go to 1 appliance, and that falls into column B, right? That's going to be at 80%. 80% of what? My nameplate value, or 6,000 watts, right? Or 6 kilowatts. So I take my 6 kilowatts times 80%, that gives me 4.8 kilowatts or 4,800 watts, right? And again, the way that I'm doing that conversion on there from kilowatts to watts is just taking that kilowatts times 1,000, and that'll give me my watts. So 4.8 times 1,000 is 4,800 watts. So what's our feeder service demand load for 2 3-kilowatt ovens and 1 6-kilowatt counter-mounted cooking unit and a dwelling unit? Well, we've got some things that fall into column A and some that fall into column B, right? So what we're going to do is we're going to calculate our column A demand, calculate our column B demand, and then add those 2 values together. And so our column A demand applies to our 2 3-kilowatt ovens, right? So we look that up, go down to number of appliances, 2. Why not 3? Because only 2 of those appliances fall into column A. All right? So we go number of appliances 2, and it says 75%. So we take 6 kilowatts times 75%, that's 4,500 watts. Right? And then our column B demand is our 6 kilowatt cooktop. That's a single appliance that falls into column B. That one's done at 80%. For a total of 4.8 kilowatts or 4,800 watts. And so our total is just going to be adding column A demand to column B demand and giving us a total of 9.3 kilowatts. Now, column C. Column C is pretty straightforward because I don't have to do any math at all as long as I'm not exceeding 12 kilowatts, right? So what's our feeder service demand load for a 12 kilowatt range in a dwelling unit? Well, all we got to do is look it up on the table, right? And so we go to number of appliances, we go over to column C, and it says 8. 8 what? Kilowatts, right? Or 8,000 watts. So it's just a straight lookup. Now that applies for anything in between 8.75 kilowatts, over 8.75 kilowatts, and 12 kilowatts, right? So if I had a 10 kilowatt range, it'd still be 8,000. If I had a 11 kilowatt range, it'd still be 8,000. Okay, so that's up to and including 12 kilowatts. Now, what about if I have something that's over 12 kilowatts? In this case, I've got a 13.6 kilowatt range. Well, note number 1 says that we're going to take for every kilowatt over 12 kilowatts, or major fraction thereof. Do you remember what that means? That means we're going to use our normal rounding rules. So for every kilowatt or major fraction thereof, we're going to increase by 5% our column C value, right? So in this case, I got 13.6 kilowatts, and so that is 1.6 kilowatts over 12 kilowatts, right? So remember, that's or major fraction thereof. So what that means is I'm going to take my 1.6 and I'm going to round that up to 2, okay? So my 1.6 gets rounded up to 2. And so I have 2 kilowatts over, and I'm going to increase by 5% my column C value for every kilowatt that I have over. All right? And so I've got 2 of them, so that's 5, 10%, right? So I'm going to do a 10% increase to column C. So if I take my 8,000 watts, and it says on the graphic times 110%. I don't like that at all, okay? And the way that they got that, let me show you up here on the board. The way they got that is they said, okay, let's take our 10%. And we're going to get rid of that. We're going to take and move our decimal place back here. And then we're going to have to stick a 1 in front of there to accommodate for the original load, all right? I don't like to do that. What I like to do is I like to use my calculator to do the heavy lifting. As long as your calculator has a percent sign, you could always do your 8,000 plus 10% on your calculator, and then hit the equals button, and it'll spit out the same exact answer as what this did, right? So I have 8,000 times 1.10, or 110%, that is going to be 8,800. All right? I think this is easier. All you got to do is hit plus 10%. I'm adding 10% to my column C value, so I find that that makes a lot more sense in my mind. If this makes more sense in your mind, go for it, okay? Just most often what we end up doing is just this, right? And we go, okay, well now I got 800, what does that mean? That's how much I got to add to my original 8,000. So a lot of times it's just one more thing that you can screw up. So we want to make sure that we try and minimize our mistakes as much as possible, right? All right, so let's get back into here. So it says times 110% or plus 10%. That's going to give me 8,800.